Multiplication on unit circle. Let's recall the polar form. So in the polar form, if the rectangular form is a plus bi and the polar form is r and theta, then r is equal to square root of a square plus b square, and theta is tan inverse b over a. Going in the reverse direction, a would be r cos theta and b is r sin theta. On the unit circle, the radius is 1 and the center is the origin. By the way, this r is called the magnitude or the absolute value, just like the distance of any point on the real number is called the absolute value or the magnitude. The distance of any complex number from 0 is also called the magnitude, and this theta is called the argument of the complex number. So argument is nothing but the angle the complex number vector makes with the positive real axis. So if I have a complex number on the unit circle, this is unit circle, x square plus y square equals 1. So say this is going to be 1 because its radius is 1. And if the argument is a, then I can write down the coordinates of this point. So I could either use a or the x equals r cos theta and y equals r sin theta, or I can recall this is how we defined cosine and sine. Cosine is the x coordinate on the unit circle, sine is the y coordinate. Now let's use another point on the unit circle. Say it has an argument of b. So this point's coordinates are cosine b, sine b. And let's try to multiply these two complex numbers. So say this complex number is cosine a plus I sine a, and this complex number is cosine b plus I sine b. Let's multiply those two complex numbers. The first complex number is cosine a plus I sine a, and the second complex number is cosine b plus I sine b. So let's make sure we are getting this right. This complex number has a real part of cosine A and imaginary part of sine A. This complex number has real part cosine B and imaginary part sine B. So that's why we have these complex numbers. And we just multiply each term here with each term there, or just apply FOIL method, multiply cosine A, cosine B, plus multiply cosine A with I sine B, you get I times cosine A sine B. Now multiply I sine A times cosine B, so I sine A cosine B, and multiply I sine A with I sine B. So I times I is I square sine A sine B. So notice that this is simply minus sine A sine B. So because I square is negative 1, I can combine the real parts. The real part is cosine A cosine B. That does not have I in it. And this one, it has I square, which is simply negative 1. So that can be written as minus sine A sine B. The other two terms have I in them. So let's write down I times cosine A sine B plus sine A cosine B. So notice, this is the formula for cosine of A plus B. And this is the formula for sine of A plus B. So I sine of A plus B. So when we multiply two complex numbers on the unit circle, every complex number on the unit circle has this form, cos theta plus I sine theta, where theta is the argument. So the first complex number had an argument of A, that's why it was cos A plus I sine A. The second complex number had an argument of B, that's why it was cosine B plus I sine B. And we multiplied and got this, cosine of A plus B plus I sine A plus B, which means the product has an argument of A plus B. So let's go ahead and draw that. And it's again a complex number on the unit circle. So this is where the product of those two complex numbers is going to be. So let's go ahead and maybe this is A plus B. So that's what we get. When you multiply a complex number with argument A with another complex number with argument B, then the product is going to be again on the unit circle and its argument will be A plus B. So it looks like complex numbers on the unit circle, when you multiply, the arguments get added up. Now, whenever and something like this happens when you multiply exponents. So recall, if you have a to the power m times a to the power n, it's a to the power m plus n. So when you multiply, the exponents are added. And that's what's happening here. When you multiply two complex numbers on the unit circle, their arguments are being added. So you say that complex multiplication on the unit circle obeys exponential law. So in fact, this is written as e to the power I times a. Because now you can see that if you have e to the power ia times e to the power ib, this is simply e to the power I times of a plus b. And that's what we notice here. So this is why the polar form is so much useful, because it gives a nice way to multiply two complex numbers on the unit circle, and we can actually extend this idea to multiplication of any two complex numbers. We will see that in a separate video.